Hey, hi! Welcome back to the series of safety sessions. I am Tota Krishna Hema, your safety expert. So, in this video, we would like to discuss about STPA in automotive safety. What is STPA? STPA is System Theoretic Process Analysis. So, in general, functional safety considers the failure of the electronic components. So, as we know that, but the STPA will also consider something like unsafe interaction of components. This method is designed for very complex systems to analyze the safe, unsafe unknowns. So, STPA is a commonly used technique in case of SOTIF. STPA we can start including from concept phase of the system, which helps in identifying safety requirements and constraints, improvise the system architecture with respect to safety. Early inclusion of STPA results in less rework, saves cost due to design flaws which generally gets identified during development or during vehicle operations. So, STPA will make you to identify the issues like much more ahead. Maybe in the concept phase only you could be able to identify the issues which we are going to face in the vehicle operations like on road. So it is based on 1940s technique called system theory. This method primarily helps in hazard identification and safety analysis. So STPA considers both software and drivers in the analysis. So whether it is an error in a software or whether it is a driver behavior issue or driver reactance issue, ensures that we considered all potential causal factors in losses for hazard analysis. With STPA usage, we will get system functionality documented. STPA can be easily integrated into system for normal development and also for model based development. In general, STPA will be used in SOTIF and also in functional safety. With SOTIF, it became more popular in identifying edge cases. Identification of hazards with the help of this STPA will cover a wide range of safety requirements. So as we said, as we discussed earlier, like if we introduce this STPA from the concept phase during this hazard identification, and this makes us to identify a lot of hazards and identifying which leads to safety goals, which leads to safety requirements, and we will avoid a lot of failures in the automotive system. So STPA in V model, where we can use STPA in V model life cycle. Okay, concept phase. In concept phase, what exactly we do is we are going to identify safety and other system goals and generate initial system requirements. That means we can use this in hazard identification. Next thing is requirements phase. Refine system requirements and constraints and generate component requirements. So for this also we can use STPA. And system architecture, assess with architectural design decisions. That means like we know that whenever we are coming across a system architecture, so we will the architect person will come up with multiple architectural multiple architectures. So we will have a brainstorming session, and we will based on the parameters we are going to take decisions. So this STPA will help you to pick up the best fit solution of architecture design decisions. it will assist in refine STPA generated requirements and identify system integration requirements and critical interface requirements. With all these things, if you consider, with STPA, like we can improvise the system architecture, system design and development, use in design and development decision making, also like generate, test and evaluation requirements, and uh, identifying manufacturing constraints also will be possible when we use this STPA in system design and development. So during this phase, like we will come to know what requirements will go to software, what requirements will go to hardware, what requirements will go to manufacturing. So what will be the constraints regarding the manufacturing, or any other things, like we will get to know here itself. So the next thing is system integration. So we have already completed design and development also. Now we have to come to the system integration. So evaluate identified integration problems should be greatly reduced. So it's like, with the uses of STPA, we are going to reduce the integration problems to a larger extent, because when you use this STPA at architecture, system architecture level only, we are going to identify the lot of interface requirements, and we are going to cover a wide range of clarity in the system architecture, so which leads in identification of integration problems much more prior than real integration happens. So even if you miss out something in the architecture, so with the uses of STPA in system integration, you are going to reduce the integration problems. So the next thing is system testing. Identify critical tests and testing regimes. So it's like when you use STPA in system testing, so we can do testing to the critical systems. So STPA usage is generally recommended for the critical systems. So it will make our life, means like the tester life, easy when we use STPA in testing. So identify critical test and testing regimes. And at manufacturing, so applying STPA to production engineering or workplace safety. So see, if you use STPA, so we could be able to identify the problems and the requirements, extra additional requirements, clarifications, interface requirements. This all we will get to know much more prior. So when okay, the next thing is manufacturing. In manufacturing also, you will get to know, like what could be the things like which we are going to provide for the production line, and the workplace safety also, the operations, maintenance and system evaluation. So for this one, we are going to, means like where we are going to use this STPA is generate operational safety requirements, generate safety management plan, and monitor for operational assumptions and leading indicators. This here also it is very important to use STPA, because the operational safety requirements definition, and the management safety management plan, and this how do you monitor operational assumptions, or how do you monitor the leading indicators, the operational indicators. So these all things we are going to see in STPA. Hope you got like where and all we can use this STPA. But STPA is very famous for the hazard identification and safety analysis. STPA goal is to identify causes leading to vehicle level losses or system level losses. We can say STPA could be able to find the cause of the accident where other traditional methods could not be able to find, since it can find all causal scenarios. So STPA is more than traditional hazard analysis methods like FTA, ETA, HAZOP and FMEA also. STPA is based on system theory. So these are the steps, like if you see in the diagram. So the STPA analysis procedure is like this. So first thing is, in rep 1 we have determine preconditions, identify accident, hazard, safety constraint, and extract component to analyze, and draw a control structure. And then we need to identify UCA, that is unsafe control action. So the ultimate use of STPA is to find out the edge cases which we could not be able to find out in functional safety. So this SORTIF, why we are using this in SORTIF is to cover the unsafe unknown area scenarios. So identify HCF, that is hazard causal factor. So this is for a control loop diagram and HCF table. So, and we can come up with the countermeasures as a end result. The other traditional approaches FMEA or FTA or these kind of things, HAZOP or these kind of things, will consider the system in a way in a different way, but wherein the STPA will consider the system in different way. What is the difference is, the traditional approach is like this: the malfunction in functional and physical components are direct and non-scenarios. So whenever there is a for example, if you consider a component like a resistor is malfunctioning, or an microcontroller is malfunctioning, so what could it result to? It is known and direct scenarios. So the mapping or interaction among components and associated events are listed below. For example, this C1, C2, C3, C4 are the C5 are the components in the system, and they are related with each other and which is represented in a dotted line. The interaction between C1, C3, C1, C2, something like that. Everything is the interactions are represented in dotted lines. There are the see, for example, if it is C1, C3 is E1, C1, C4 is E2, something like that. There is a chain of events which will result in this thing. So what is system theory? The system is treated as whole, not as a sum of the parts. You have probably heard the statement called the whole is more than the sum of its parts. So if you consider the whole system, so you could be able to consider the individual components of it and the interaction, everything in the system, the functional, non-functional parts of the system will be covered as in the when you consider it as a system. So but wherein so that is called system theory. So a primary concern is emergent properties, which are properties that are not in the summation of the individual components but emerge when the components interact. Emergent properties can only be treated adequately by taking into account all the technical and social aspects. So emergent properties arise from relationships among the parts of the system, that is by how they interact and fit together. So this is the emergent properties which are mentioned arise from complex interactions. So a system component interacts in direct and indirect ways. The whole is greater than the sum of the parts, which is written in blue color text there. So we have other representation of the system. Anyhow, it is it is a interaction between the components. So those components are marked as blocks here in both the diagrams. But here in system theory, we will have control actions and feedback. So this is called a control loop. If you remember the control systems engineering, so this is a basic concept, the output will get adjusted by considering the continuous feedback from the system. So the controller will be there, which will be controlling emergent properties, that is enforcing safety constraints, individual component behavior, component interaction. So it will send as an output to the system with control actions, and from the system we will take the feedback, and this is called feedback loop. STAMP is system theoretic accident model and processes. STAMP is the basis of STPA. That means it is a basic step of STPA. It is a top-down approach. It's not a step actually, like based on STAMP we came up with the solution called STPA. We can say that it has a basis for STPA. It is a top-down approach, and STAMP is not an analysis method. It is a model or set of assumptions about how accidents occurs. So STAMP is an alternative or a chain of failure events like dominoes effect that underlies the traditional safety analysis techniques. So it includes software, human, organizations, safety culture, etc. as causal factors in accidents and other types of losses without having to treat them differently or separately. It allows creating more powerful tools such as STPA, accidental analysis, CAS, that is causal analysis based on system theory. So this is another analysis method of accident which is similar to STPA. Like STPA we do for safety analysis, right? The same way CAS will be used for accident analysis. So causal analysis based on system theory, and identification and management of leading indicators of increasing risk, organizational risk analysis, etc. STPA is a proactive analysis method that analyzes the potential cause of the accidents during development so the hazards can be eliminated or controlled. So here are the STPA steps. So if you see this right side diagram, so it is already discussed before, but however you can easily relate now with both the diagrams. STPA steps, it is you need to remember these 4 steps. First thing is like define the purpose of analysis. For what you are doing this system level analysis or vehicle level analysis, okay? For what you are doing it, what is the purpose behind it? So what is the purpose means to identify hazards, or to identify the losses, to identify the boundary, or to identify the environment or environmental conditions. So for what you are doing is we need to write that. The second thing is model the control structure. So controller will be there, controlled process will be there, and there will be in between output as a control action, and the output from the controlled process is feedback. So a controller will control the process based on the feedback given by the system, okay? And model the control structure. Once after modeling the control structure, we need to identify unsafe control action. Unsafe control action is something like see, we have a control action which, see, sometimes like based on the feedback provided by the system, so the controller will alter the control action. So but there will be a scenario which occurs like the controller could not be able to send a proper control action, so that is called unsafe control action. So it can't mitigate, or it can't suffice it is not sufficient to sufficient for the system to get a proper solution. So that is called unsafe control action, UCA, unsafe control action. So then after identifying unsafe control action, you need to identify loss scenarios. So loss scenarios is like determine the scenarios leading to the unsafe control actions and other system hazards. So if you see this right hand side diagram, so STP analysis procedure. So first thing is you need to identify the purpose of the analysis. That means determine preconditions, identify accident or hazard or safety constraints, or extract components to analyze, and then draw a control structure. So this first preparation one is nothing but define the purpose of the analysis. Next thing is draw a control structure is nothing but model the control structure step. And then we need to identify UCA, that is unsafe control action. And then we need to identify, based on the identification of unsafe control action, we need to identify loss scenarios. So loss scenarios is like how do you this loss scenarios will be on the vehicle basis. So identify HCF, that is hazard, causal factor, that means control loop diagram, HCF table, and countermeasures. Countermeasures are the outcome of this entire STPA procedure. With this, I came to the end of this session. So if you like this concept, please click on the like button. If you want further more automotive videos, subscribe to my channel. Thank you.